So in this video, we're going to show you how to create VMs in the United States and Canada from your Cartika portal. In order to enable this, we've purchased two different accounts. One is the Cloud VPS in Canada, one's the Cloud VPS in the United States. And within each, we purchased two resource pools. So within the United States, we purchased SATA disk and SAS disk. So we've got a pool of resources both on SATA in Dallas, SSD in Dallas, and within SATA in Toronto and SSD in Toronto. So the first thing we're going to do is create some VMs. In Toronto, we'll create the web server VMs on SATA, and we'll create database VMs on SSD. So in Toronto, SATA, you can see the resources we have available as follows. We're going to create two VMs with these resources. If we want to add additional resources, whether it's just disk space or additional CPU, RAM, or combination of each, and whether it's to add to an existing VM or create new VMs, this is where the additional resources would be purchased and ordered, and then they're available within your resource pool here. So for now, we're just going to create a VM. As you can see in SATA in Toronto, we do not have any VMs created. So we're going to call our first VM CAD Web 1 for Canada Web 1. We're going to select a Linux operating system. We're going to select a Red Hat flavor. We're going to go with CentOS 6.3. As you can see, we have many options here under this brand available. We're going to generate a random password. Again, I want to create two VMs, so we're going to make this 512 megs of RAM, which will leave us another 512 for a second one. One CPU core, leaving us an additional CPU core for a second VM. And in this case, we're going to create a 23 gig VM with 2 gigs of swap space. I'm going to create the VM. While that VM is creating, you can see it's a pending status right now. I'm going to add the second VM here. And let's call this CA Web 2. Again, I'm going to make it CentOS 6.3. I'm going to generate a random password. It's allocating me the 512 megs of RAM we have left, the CPU cores. I'm going to make it 23 gigs to match the previous one and 2 gigs of swap to match the previous one. Because in a future video, we will be load balancing these servers and showing you how to do that and create. So now you can see here there's two VMs in a creating status. And what I'm going to do now is I'm going to go in and create an SSD VM in Canada to be the database server. So in this case, I'm going to call it CAD MySQL 1. Obviously, you can use several database platforms, PostgreSQL, MS SQL on Windows, MySQL, MongoDB. There's several other different options, Percona, MySQL. We have many of them pre-bundled and packaged into templates. Additionally, you can just install default Linux OS templates or Windows templates and install whatever database or database platform you want. We're going to call this one MySQL 1. I'm going to choose a MySQL template with it pre-installed. Again, I'm going to generate a temporary password. I'm just going to create one single database server, so I'm actually going to use all the resources we have here. Again, I'll do 2 gig swap space, and I'll create this VM. So now in Canada, we have 2 web servers created on SATA. You can see this one's completed and this one's still pending, and 1 SSD-based MySQL VM. And now we want to connect the web VMs with the database VM, the MySQL VM, via the LAN network. So what I'm going to do is I'm going to go to each VM. I'm going to go to the network. I'm going to go to my interfaces because you can see here we have ETH0, which represents a public-facing IP at 100 megs. And I'm going to create a new interface for the LAN-facing network. I'm going to call this one Ethernet 1, and I'm going to choose private network, and I'm going to make it 100 megs per second. Now I'm going to go to IPs. I'm going to assign a new IP address to the newly created interface we just did. I'm going to call the interface 1, ETH1. I'm going to select one of the available LAN network IPs. So I'll take the next one in order, and I'll assign. Now, because we've made so many changes, I'm going to rebuild the network. It's probably an unnecessary step, but I'm going to do it anyway. And that'll just make sure all the configurations are posted properly. So now if I go to my servers, you can see CAD Web 1 is now pending because we rebuilt the network. CA Web 2 is completed building and ready to go. I'm going to perform the exact same steps here. I'm going to network interfaces. I'm going to create the LAN network on this interface. And lastly, I'm going to assign an IP to this Ethernet 1 interface, a LAN IP to this Ethernet 1 interface. Again, here's a list of available IPs. This time I'll pick one at random from the available pool. I'm going to assign the IP address. I'm going to rebuild the network. And I'm going to do the same with the MySQL server. Again, I'm going to assign the network interface to it, so I'm going to create Ethernet 1, representative of the LAN network. And lastly, I'm going to assign an IP to that new network. And for consistency's sake, I'm going to rebuild the network. So what we've effectively done here is in Canada, we signed up for a SATA pool and an SSD storage pool within the Canadian facility. We created 2 virtual machines on the SATA tier, Web 1 and Web 2. We created a virtual machine on the SSD tier, MySQL 1, and we created a LAN network to enable the 2 web servers to communicate with the SSD server. In a future video, I'm going to show you now how to load balance these 2 web servers, and potentially in a video after that, we're going to show you how to utilize our Anycast DNS in combination with load balancers to create a high availability array between the United States and Canada, i.e. a geographically dispersed high availability array. Lastly, even though we created these VMs in Canada, we still have these resource pools available in the United States. And in a similar manner, we can create virtual machines now in the United States and or from Canada. And of course, via what we call our command layer, everything essentially integrated and ready to go.